Welcome to Calculus 2 course. The video's topic is derivatives and indefinite integrals. We know how to take derivatives of the functions. So if I apply the derivative operator, for example, if I want to apply the derivative operator for the x squared, I will get 2x. If I apply the derivative operator for x squared plus 1, I will get also 2x because derivative of 1 being a constant, it is equals to 0. The derivative of x squared plus pi, also it is 2x. Pi, it is a constant, its derivative is 0. In general, derivative of x squared plus c being a constant, is 2x. Let's go the other way around. So I will talk about antiderivatives. That means the opposite of derivative of operator. So the reverse operation of finding a derivative, it's called antiderivative. So a function f is the antiderivative of the small f if its derivative equals to f. In other words, given some expression, we want to find what it could be the derivative of. In my case, what is 2x the derivative of? I would say derivative of x squared is equals to 2x, so it's fine. X squared plus 1, also it is an answer, its derivative is 2x. X squared plus pi as well, and in general x squared plus c being a constant, it is the general answer. It is kind of difficult to list here and to write in this way. We need a notation. So the notation for the antiderivative, it's using this elongated symbol. And the family of all the functions that are antiderivatives of the function f is called indefinite integral. So let's discuss about this symbol. This elongated sign is called integral sign. F of x, the function that I'm talking about, is called integrand, and dx here shows me x is the variable that is involved in the antiderivative. This symbol altogether is actually the indefinite integral, and the answer is this family of function. Don't forget plus c, the constant of integration. Using this integral sign, I will write integral 2x dx equals x squared plus c. Also, integral, for example, 3x squared dx. So what is 3x squared, the derivative of? I will say x to the power of 3 plus c. What about integral only x2 dx? I would say I need to put down the 3, so x3 over 3 plus c. By reversing any derivative formula, we get a corresponding integration formula. The formulae that are listed in here are obtained using this strategy. Let's have a look on the first one, that is called integration rule, power rule. Integral x to the n, xn plus dx, xn plus 1 over n plus 1 plus a constant c, attention, n not equals to minus 1. Let's go for an example. Integral x to the power of 5. So it is n plus 1 x6 over 6 plus the constant c. The second rule is related to the exponential function. Integral e to the x dx, it is equals e to the x plus constant. Its derivative of e to the x plus c, it is e to the x. The case that was omitted in number 1 rule, n equals to minus 1, it's here seen in number 3. N equals to minus 1, x to the minus 1 is 1 over x. Its integral is natural logarithm of absolute value of x plus c, because the derivative of the natural logarithm is 1 over x. 4 and 5 are general rules for the functions f and g that are continuous. So integral k f of x equals k f of x, where k is a constant. What means this? The constant factor can be moved across the integral sign. Attention, k is a constant. It's not true for the product of two functions. Rule number 5, integral of the sum or difference of two functions, it is equals to sum of the or difference of the integrals of each function. Let's go for some examples. Integral 2. So what is the function? The derivative is 2, of course, 2x plus c. The second one is integral for a polynomial function. Applying properties number 4 and number 5, I will distribute the integral sign to all the terms. So 2x5 dx minus integral 3x2 dx plus integral 1 dx. And I will take 2 across the integral symbol. 2 integral x5 is x6 over 6. Minus 3 integral x squared, rule number 1, is x3 over 3. Plus integral of 1 is x plus c. Simplifying 2 and 6, here getting 3 and 3, the simplified answer is x to the power of 6 over 3 minus x cubed plus x plus c. What about the third example? The 4, it's moving across the integral sign, but what about fifth root of w to the power of 3? The radicals can be written using the rational powers, using this formula. A reminder for the formula: nth root of a to the m is a to the power m over n. Writing fifth root of w to the 3 as the power 3 over 5, we are applying the first rule, that is the power rule. So 4 times w to the power 3 over 5 plus 1 over 3 over 5 plus 1 plus constant c equals 4 times, here I get 8 over 5 and reversed is 5 over 8 w to the power 8 over 5 plus c. Simplifying, I get 5 over 2 w to the power 8 over 5 plus c. And finally, the fourth example of the video. Integral 5 over x minus 4e to the x. So I will split into integrals and the 5 moving across the integral sign. Integral 1 over x, as per property number 3, is logarithm natural absolute value of x. The 4 is out of the integral sign, so it's 4 in integral e to the x plus c. Thank you.